Right, here is our Chapter 1 Quiz 2 study guide review video. For the question 1, it's asking how is subtracting integers and rational numbers related to adding? Well, remember, if we think about it, subtraction we've been using is the opposite of adding. Okay, so if when we look at our problems, we do the opposite of what it's saying, we will eventually get to a point where I can make an addition statement and a subtraction statement that have the same answer. An example might look like this, right? If I have 4 minus 3, or 4 take away 3 positives, we can also think about it in the same way, saying, hey, take 4 and add 3 negatives. Okay, both of these are going to result in an answer of 1, except in one way, I'm using subtraction, and in one way, I'm using addition, where I'm just kind of flipping around where my signs are. Okay, for number 2, that kind of leads right into this. What process do we use to change subtraction problems into adding problems, right? We just add the opposite. Okay, we've called it karate math. Okay, whenever I'm given a problem, maybe it looks like this. I'm going to take and do the exact opposite of what it says. Take away -1 becomes add +1. So we want to rewrite the expression by adding the opposite, then evaluate the expression, write the fractions in simplest form if we have fractions. So starting with number 3, again, I'm going to do the opposite here. This is a chop-chop situation. Okay, so I have 8 plus +10, which is 18. For number 4, I'm going to rewrite this. I only do things after the first number. So I have a chop and a slash coming here. So I have -5 plus -9. Two negative numbers being added together. Add like normal. 5 plus 9 is 14. But since they are negative, we have to make this negative. Number 5, I have -6.7. And then I have minus -8.2, or minus negative. Well, that's going to turn to plus positive, do the opposite. So now I have -6.7 plus 8.2. These two have opposite signs, so we're going to subtract them. We're going to borrow here. 12 minus 7 is 5. 7 minus 6 is 1. So I get 1.5. I'm going to check my signs and see that 8.2 is positive and it's my bigger value. So my answer is going to stay positive 1.5. For number 6, okay, we're going to keep this. I have a subtraction sign, so I'm going to add the opposite. So I'm going to add -5.3. I have a positive and a negative. We're going to take our bigger value and subtract our smaller value from it. Notice this time when I line my decimals up, I'm going to need a placeholder 0 in 5.3. Then I'm going to need to borrow. I get 2, borrow again. I get 7, and that's 0. Okay, so now I'm at 0.72. I got to check my signs. This one has the bigger value. It's negative. So my answer is negative. Number 7, I'm subtracting fractions now. Okay, first step, I need to add the opposite. So add -1 3/5. So I have 4/5 plus -1 3/5. Okay, I need to convert -1 3/5 into an improper fraction, which looks like this. 5 times -1 is -5, plus -3 is -8 over 5. +4, -8. Well, if I think about it in terms of these two sides going against each other, the negatives have more people, so they're going to win out, and they win because they have 4 more people than the positives, or 8 plus negative, or sorry, -8 plus 4 is -4. All right, finally, number 8. This is a situation where we can kind of practice moving around numbers to help us out a little bit. All right, we have a commutative property that says, okay, we can move around numbers as long as we're doing the exact same thing. So before we start, I'm gonna make this into a chop slash or a plus negative. And now what I can do is I can flip-flop these two using our commutative property and setting me up to see something really nice. Okay, now from here, right, -7 eighths plus -1/8, well, that's -8/8, which is really just equal to -1. And now I can do -1 plus 3/4, right? -1 is over 1. We can change it to have common denominators by making it -4 over 4 plus 3 over 4. Okay, -4, +3. When they add together, they're going to subtract. 4 minus 3 is 1. I have 4, and this is negative since 4 is the greater value. All right, number 9, show the distance between the two numbers on a number line. So what we have here is this, I put 0 down. 1.4 is pretty close. -6.2 is pretty far away. What I'm trying to figure out is how far is this distance? Okay, so if I measured this distance from here to here, and then added this distance, I will get my total distance. So I'm going to start with my greatest value, okay, or sorry, my greatest number right now, which is positive 1.4. I'm going to subtract my opposite number, which is -6.2, and then I can see that I have subtract negative, so we're going to add positive. 1.4 plus 6.2 is going to end up being 7.6. Okay, remember distance is always positive, so we should be looking for a positive answer. Okay, for number 10, on the number line, here's 0. 2/5 is before 1. Okay, and it's kind of like right here. 1 1/10 is right after 1. Okay, and we're trying to find this distance here. So really, I could try and find my distance from 0 to 1 1/10, and then I could take away this portion of it and only look from here to here. So my biggest number right now is 1 1/10. We're going to subtract my other number, which is 2/5. Okay, 1 1/10. If we multiply 10 times 1, we get 10, plus 1 is 11. So I have 11/10 minus 2/5. Okay, 2/5 we could change into 4/10 to make common denominators. 11 minus 4 is 7. And we get a distance in between these two numbers of positive 7/10. All right, two more here. Number 11 says a container of sugar contains 9 teaspoons, and each morning you put 1 teaspoon in your coffee, and each night you put 1 1/4 in your tea. How many days until the sugar runs out? Provide evidence for your answer. Okay, so first of all, what we should do is we should figure out in a day how much total sugar are we using. Well, we use 1 in the morning, and we use 1 1/4 at night, meaning in total, if we were to go through with this, okay, I would have 1 over 1 plus, converting this, I get 5/4. Okay, changing 1 over 1 into a common denominator, I would get 4 over 4, meaning I use 9/4 worth of sugar each day. Okay, so it says it's 9/4 or 2 1/4. And we're looking to see how many days can I use until I run out of sugar, which was 9 teaspoons. Okay, so here we go. We're going to set this up. At day 0, right? It hasn't been a day, I have 9. At day 1, okay, I'm going to take away 9/4 worth of sugar. Well, I'm going to subtract here. These I need to change to make common denominators. So I'm going to have 36 over 4 minus 9 over 4. and we end up with a day one after day one with 27/4 left of sugar. Okay. Well, on day two, then we're going to use the same exact amount, meaning we're going to subtract 9/4 away. 27 minus 9 is now 18/4. Day three comes and we use another 9, so we're going to take away 9/4. And we end up at 9/4, meaning on after day four, when we take away our 9/4, we end at 0. So what it's asking is how many days was it until my sugar ran out? Well, we had enough to cover 4 days worth of however much sugar I use. 1 teaspoon in the morning and 1 1/4 at night. Okay. For number 12, okay, it says at 9 p.m. the air outside is at an unknown temperature. The temperature then drops 16 degrees overnight, then rises the next morning. The thermometer shows the temperature throughout the time span. So, two questions here. One, we want to see how much did the temperature rise after it dropped. Okay. Then what we want to do is we want to label where did we actually start? What was the original temperature at the start of the night on the thermometer? Okay, so what are some key pieces we have here? Okay, I don't know where I started. Okay, I know that it dropped 16 degrees. So this means minus 16. Okay, it then rises the next morning. And after rising, we end up at 25 degrees. We also know after it's done dropping, we ended at -5 degrees Celsius. Okay, so what we want to see is how much did the temperature rise after it dropped? Well, after it dropped, we were sitting at -5 degrees. And then after rising, we were at 25. So what we're going to do is we're going to subtract these. We're going to put our bigger number first, 25 degrees. And we're going to take away where we started, or where after it dropped, which would be -5. Okay, this would result in a chop-chop situation. 25 plus 5 means we rose a total of 30 degrees Celsius, which makes sense, right? I needed to go 5 to go from -5 to 0. And then afterwards, we raised it another 25 to get to 25 degrees Celsius. Okay, now it says to label the original temperature at the start of the night on the thermometer. This is where it gets a little interesting. So we know that we started at a greater value and then it dropped. Okay, that's the first thing it said. So we know we started somewhere, it dropped, subtracted, and then we ended at -5. Okay, how much did it drop? Well, it dropped 16 degrees, so I'm going to say, hey, this is something -16. Okay, and where did I start? Well, that's what we're trying to figure out, right? In my head, here's what I am thinking. I know that if this had been 16, I would have ended at 0 degrees. So I know it's not that. If I put any number bigger than 16, say 17, okay, 17 minus 16 results in a positive number. Okay, 18 minus 16 is +2. 19 over 16 is +3, right? We're looking for now, I'm looking to try and get a negative number, but if I go anything bigger than 16, I keep getting positive answers. So I know that my number that is right here has to be smaller than 16 in order for my answer to be negative. Okay, well, how much smaller does it have to be than 16? Well, it's got to be that value. It's got to be 5 degrees smaller than 16. Well, what's 5 less than 16? Our temperature that we started with has to be 11 degrees. Okay, if we did this out, 11 minus 16, chop slash. Okay, we end up getting 16 minus 11, which is 5. 16 in this case is negative, which is exactly the temperature we want. So on our thermometer, we're going to put a line and say that we started at 11 degrees Celsius. Okay, we drop 16 and then we rose 30 degrees. Okay. There is our chapter 1 quiz 2 review help sheet.